Hey everybody, this is Larry. This is day 29th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this prompt. 2 more days to go, so yeah. Find first and last element and sort it away. And yeah, okay. Yeah. I usually solve these live, so you know, if the explanation is a little bit slow, watch it on 2x or something like that. So there are a couple of things, and obviously if you do it in linear time, that's too, I mean, you can, but you know, people would not be happy about it, I don't think, or I would be like, okay, that was an obvious thing, you could do a for loop, can you do better, right? And the login time is actually not that hard either. It's just binary search because it is sorted away. We take advantage of that. There are a couple of things we can to think about in this one. Maybe not that many, but the most obvious one is just that, you know, you can just the most obvious one is just using a library is what I was going to say. Basically, you can do something like bisect left, nums of target, and then bisect right, nums of target -1. I mean, it's not quite the answer because we have to do the answer not existing case, but that'll give you the answer, right? Roughly speaking, we have to change some, you know, thingies, but yeah, see, like that works. Let's just try 9 and then I don't know, 6 or something, right? I don't or empty array, I guess is the other one. But yeah, so it'll give you like some random answers, and you can and you know, and there are definitely things you can do with this one in terms of just checking, you know, the answer. I mean, you could probably maybe see a pattern about this from how the definition is to return -1, -1 instead. I'm not gonna go over it that much because this is not that, you know, this is not that interesting. So instead, I'm gonna go over binary search in using this problem. You know, because this is just really silly. Otherwise, right? Like we're pretty much done. During a contest, I might do it, but I don't think you'll see something that is this direct on a contest. You will at least see it dressed up or disguised a little bit, I imagine. At least nowadays. Okay, so now you want to find 2 things, right? Yeah. How do I want to kind of phrase it? So you can definitely write 2 binary search for this problem, and the thing that I'm thinking about now, just really quickly, is how not to return, you know, write it twice. But let's just return the first one, right? Let's have a function that's called find, and let's define it first. Find returns the first element, or the index of the first element of target, right? Or first element that is greater than or equal to target. Why did I say it's phrased like this instead of just, you know, equal to target? Is because I guess maybe we don't have to. I like to phrase it this way, but maybe we could just do this. That is equal to target, right? So yeah. So yeah, that's pretty much the idea. And then, oh no, the reason why I want to do it is because of something that I'll show later. Yeah, that's right. So let's say this is fine. Let's start with, you know, the way that I always write it. There are a couple of people with, or like there are a couple of patterns that people like. The way that I would like it is just, you know, right as you go to, let's say nums sub, yeah, this -1. So basically what I like to is phrase how, you know, you have to phrase your question exactly in binary search so that you can answer the question very precisely. For me, we want the bounds to be inclusive, like left, right. So they're inclusive, meaning that both left and right are in the bound, right? And this allows me to write the next statement very easily. While left is not equal to right, basically, because if left is equal to right, then the bound is left right, which is you go to left left, say, which is you go to one number, and that's your answer. Yeah, this is the way that I like to think about it. You know, yeah. And then the second one is just left. The middle is you go to, you know, division by 2. I know that you know, in certain languages it can overflow, so there are different ways of writing this, but I'm gonna ignore it for now because we're in Python. So yeah, and then now we just have to try mid, right? And then, you know, and here, how do I want to say this? Generally, I will replace this with a good function. So let's do this, right? If this is good, right? And what is good, right? Good of index. So, you know, for this function that we're trying to write, it is good if num sub index is greater than or equal to target, because that's what we define, right? Okay, so if this is good to mid, well, let's go back a little bit and think about our binary searchable function, right? So we reduce this number series to a binary series that starts with, you know, false, and then true, right? And then the only two scenarios, right? Now, the only two scenarios, which is that our mid is either here in false somewhere or in true somewhere. So let's go through them, right? If this is good, that means that we are in true somewhere. And what does that mean? That means that in this problem, we want to find the first index, so then the index is to the left. And that means that we could throw away everything to the right, right? We can throw away everything to the right, but the pointer that we're still pointing at is still good. So that means that we want the right to equal to mid, because right is inclusive and middle isn't, you know, it's inside the possible range. So we want to keep mid. And then conversely, if we're in the false, well, we know that everything to the left of it is bad, but also the actual index that we're checking, mid, is bad as well. So then we can, you know, then we can throw away this index and everything to the left of it. So we want to keep everything to the right of it. So inclusive of that, this index is left plus 1. So that's why you see sometimes, you know, you get this thing, right? And that's pretty much it. And then now we can return left. Yeah. And then now the reason why that we can find it, and this obviously converges, you know, I'm only explaining this part, but yeah, now we have an answer is equal to find target, oops, and then just find target minus 1, say, right? Because this is going to be the first index. Oh, sorry, this is plus 1, my bad. I said minus 1 twice and I didn't. But yeah, this is the next number, and then we want to subtract 1 to get the, you know, you could write another for loop, but yeah, that's basically the idea. This is not going to be right, as we said, because we don't take account. You know, that number not being in there. But we can just add a simple if statement, which is that if answer of 0 is equal to negative, okay, so if the nums of this is equal to or is not equal to target, then we return -1, because that means that this is the number that, you know, matches our target, and if that target is not in the array, then that means that it doesn't exist in the array, so we just return -1. Let's give it a go. Hopefully that's good. Oh no, oh yeah, I did miss this one. Which is that this may go outside the bounds. So let's just check that. If this is less than length of nums, and this. Oh wait, actually I've messed up. This should be if this is greater than or this thing. Without even looking at it, because I realize what I'm doing. But yeah, so that looks good. So yeah, so I want to go back well, let's give it a submit first, but I just want to go back a little bit to say that well, let me give it a submit first, because if I do have it off by 1, it's embarrassing. Oh no, I do have an off by. Oh, huh. That's awkward. Why would it give one for? Maybe I should have done 2 of these. Let's see. It finds 2. Oh, because I kept this inclusive. But how do I want to fix this without adding a second thing? Let's see. So it goes from 0 to 0. So it returns 0. Except for then it minus 1. So I guess this is an edge case. Because usually what happens is that technically what I did was wrong in that. And actually, I suppose, because if we put the target as 2, this is violated, right? So in this case, we need to get the right side, and yeah. Oh, oops, I didn't copy this one. Okay, so now that's fixed. Yeah. Let's give it another submit. Okay, cool. And the reason why that is thing is that we want these to be exclusive, but the element, the space, if you will, after the last element is a valid input because your target is bigger than all the elements. I usually do this correctly, but I think I was thinking about a similar problem, but I changed up in the middle. But yeah, but I would say, and that goes back to my point, which is that for binary search, everything is really precise in how you define the bounds. And if you see yourself having off by ones, make sure that, like I know that people quote unquote find these patterns and they just memorize them, and that's fine maybe, except for when you get asked variations and then you just couldn't debug them. But if you kind of follow through each of these questions in a standard way, and one day I'll do a binary search video by itself, so I could go over all the different variations. But if you're kind of consistent about asking the same question or the right question for binary search, then the code writes itself, which is what I like to kind of think about. And that's why I have like stuff like this, because then, here I could see myself like the index follows each other depending on what question you're asking, right? For example, if you want to be the last force, then you just, you do things in a little different way, for example. Okay. But yeah, it goes without saying, obviously, this is binary search, so this is log n, and we do 2 log n operations at most, or actually, I guess we always do. So it's going to be O of log n. If we use O of 1 space, we just have a couple of pointers and so forth. So yeah, that's all I have for this problem. Let me know what you think. Hit the like button, to subscribe, and join my Discord. Last day of the month, let's get it done. To good mental health. See you later. Bye bye.